Greetings. In this video, we shall discuss regarding the well hydraulics and the methods of determination of yield from an open well. So why to study this well hydraulics? Always we used to say or hear that there is a scarcity of water. The surface water storages, maybe in terms of ponds, dams, they are going to decrease and decrease and decrease. Now peoples are concentrating more on the groundwater. There is a withdrawal of tremendous amount of aquifer. So there is a over exploitation of water from the groundwater. Therefore, we need to understand well hydraulics to design a pumping strategy that is sufficient to furnish the adequate amount of water. That's why we have to study this well hydraulics. Now coming to well hydraulics, now this is the well penetrating into unconfined aquifer. Already we have discussed regarding unconfined aquifer. Unconfined aquifer means which is not confined. It is not lying between two impervious layers. By the bottom there is impervious layer, but in between you will not find impervious layer. And in case of this, the water pressure is atmospheric pressure and the water level is at groundwater table. So this is called as unconfined aquifer. So this is called as pumping well, and these two are 1 and 2. This is 1 and this is 2. These are the two observation wells. In case of this, one well is called as major well is called as pumping well. Rest of the two wells are observation wells. Well number 1 and well number 2. Consider the water in an unconfined aquifer being pumped at a constant rate from a well. It is assumed that the water from this unconfined aquifer it is pumped at a constant rate from a well. Prior to the pumping, the water level in the well indicates the static water level. So this is the static water level. So prior to the pumping, the water level in the well is static water level, constant water level, stable water level. A lowering of this water level takes place on pumping. When you start pumping, definitely there will be lowering of this water table. It will go on reducing and reducing. Due to the radial flow into the well through the aquifer, the water table assumes a conical shape called as cone of depression. So when after pumping, there will be lowering of this water table and there will be flow. In fact, from the aquifer or from the strata, there will be horizontal flow. But as this water table in the well due to pumping will go on decreasing, it will take this type of curved shape, conical shape, and this is called as cone of depression. So this is called as cone of depression, is also a cone of depression. The drop in the water table elevation at any point from its previous static water level is called as drawdown. So what is drawdown? The drop in the water table elevation at any point from its previous static water level is called as drawdown. So from here to here, this is called as drawdown. When water reaches the initial water table, afterwards it will go on reducing and reducing, and this up to this, it is called as drawdown in the pumping well. This is the drawdown in the observation number 1, and this is the drawdown small amount observation number 2. The areal extent of the cone of depression is called as area of influence. The areal extent of the cone of depression is called as area of influence. So from here to here, this is the area of influence. The areal extent of this cone of depression, this is a cone of depression. So it is called as area of influence, and its radial extent as a radius of influence. So radial extent from center of this pumping well up to this intersection point of this curve to the static water level. This is called as a radius of influence from center of pumping well up to this intersection point, radius of influence. So all these technical terms It is asked in the exam. What is cone of depression? What is drawdown? What is area of influence? Or what is radius of curve? Or sometimes short note on well hydraulics asked in the exam. Right? Apart from this, you won't have to bother about any other things. Please remember. So this sketch, it is very easy sketch. You can show this impervious strata, and then you can show this type of pumping well. Addition two wells as observation wells, and this as static water level, and this as a ground surface, and then this is initial level, this is the drawdown, this is the drawdown curve, right? Radius of influence and all those things. Please get it understood technically. Now coming to assumptions for radial flow. While now in case of this also we have assumed that flow in the well is the radial flow. This is one type of assumption, right? Or one may say that always there is a horizontal flow of water. No doubt there is a horizontal flow, but as and when there will be drawdown, it will, if the strata is a pervious strata, right, definitely it will take a conical shape, it is curved shape. So there are Dupitt and Thiem assumptions for a radial flow. Sometimes question may be asked, write down the Dupitt assumption. Sometimes question may be asked, Thiem assumption, Dupitt and Thiem assumptions, or any assumption, write down the same assumption in the exam, you will get full marks. So what are the assumptions? The aquifer is unconfined. The aquifer has infinite aerial extent. The aquifer is homogeneous, isotropic and uniform thickness. Isotropic means permeability is same. The water table is horizontal prior to the pumping. The water table is horizontal prior to the pumping. The aquifer is pumped at a constant discharge rate. Pumping is with constant discharge. The well penetrates the full thickness of the aquifer. The well has been penetrated into a full thickness of aquifer. The flow is laminar flow and Darcy's law is applicable. The important assumption is the flow is treated as a laminar flow into the well, and Darcy's law is applicable. Q equals to K into I into A. The coefficient of transmissibility is constant at all places and at all times. Coefficient of transmissibility or transmissibility T equals to K into B. K is the coefficient of permeability or hydraulic conductivity, and B is the thickness of aquifer, thickness of the stratum. So these are the assumptions. You have to mug up all these assumptions. Now coming to yield of an open well. What is yield? Yield is nothing but the amount of water which can be contributed by the well, which can be discharged by the well. So this is called as yield. The yield of an open well can be determined by following two methods: constant level pumping test and recuperation test, which I'll discuss. Only constant level pumping test in this video, and second, that is recuperation test in detail in the next video. So what is constant level pumping test? In this test, water is pumped from the well so that the water level in the well is depressed by an amount H known as depression head or drawdown, as shown in the figure. So in case of this constant level pumping test, a pump having sufficient capacity is arranged and the water is pumped through the well till it achieves a certain depression head known as H. The rate of pumping is then so adjusted that the water level in the well remains constant. So in case of this, one has to adjust the rate of pumping in such a way that the water level in the well remains constant. That is the difficulty with this test. In this condition, the rate of pumping will be equal to the rate of yield from the well at this depression head. So in case of this, the pump has to be arranged in such a way that the outcoming water will be equals to incoming water. And in that case, it will be the yield from the well for that depression head. For a depression head to which the discharge or pumping rate, it is adjusted, it is constant. The rate of pumping of water is measured by a suitable discharge measuring device. Suitable discharge measuring is used and then discharge is measured. So what is done in case of this constant level pumping test? As its name suggests, level is maintained constant in the well. So in case of this, A pumping arrangement with sufficient capacity is orange. The water is drawn from the well, and then afterwards the discharge from the well or the pump is arranged such a way that incoming water is equals to outgoing water. The discharge, outgoing water is measured, and it will be a discharge, or you can say yield, from the well. So this is the sketch, self-explanatory sketch for constant level pumping test. Now, how discharge can be calculated analytically by Darcy's law? So Darcy's law is used for determination or measurement of the discharge. Q equals to K into I into A, where K is the coefficient of permeability. Here I is nothing but the hydraulic gradient H upon L. So here H is nothing but it is the depth of drawdown. So it is a drawdown. L is the length, total length of the well, and A is the cross-sectional area, where SW depression here or drawdown. Rearranging Q equals to K by L. L is separated from this into SW into A. Q equals to K by L, SW into A, and this is used because here one can measure SW, that is drawdown in the well, one can measure cross-sectional area knowing the diameter of the well, one can find out the area. So SW can be measured, A can be calculated, and KL should be known. It is a coefficient, it depends upon the material of the well, right? So discharge can be calculated. So K by L is the percolation intensity coefficient. It should be meter per second per unit head, right? This is the given parameter. A is the cross-sectional area of the well. Q is the discharge in Qmax. From equation 1, the discharge at any drawdown can be calculated. So knowing the drawdown in the well, one can find out a discharge through the well. So this is all about constant level pumping test and well hydraulics. So with this we shall stop here. In the next video we shall discuss regarding the recuperation test. Thank you.